Thanks, Steve and John. Good morning and welcome to VelocityConf. I'm glad you guys picked loose-fitting outfits and costumes this morning, other than the Speedos and unitards, which would have been quite alarming this morning. So anyway, so I want to get started here. For most people, Facebook is something pretty simple. It's a website you visit every day. It's where your friends and family are. It's your news feed, it's your photos, it's your messages, it's your crops on Farmville, it's your memories, it's your online identity, and it's your timeline. But all of this rests on a pretty complex foundation. And behind the scenes, Facebook is something else. Today, Facebook's infrastructure supports nearly 1 billion people around the world. 80% of those people live outside the US. 500 million people visit the site every day. Each day that passes, the data that we manage grows more complex and becomes more interconnected. We have to build systems that keep pace with the imagination of the planet. So I want to give you some idea as to the scale that we operate our infrastructure at today. So I'm going to run through a bunch of stats. Just keep in mind that as I run through these stats, this stuff will take place on Facebook in the next 30 minutes. So today, we will ingest 10 terabytes of log data into Hadoop in 30 minutes. That's the equivalent of processing about 1 million phone books. We scan about 105 terabytes of data on Hive. That's the equivalent of processing 5 times the text in the Library of Congress in 30 minutes. We process and upload 6 million photos in 30 minutes. 160 million new newsfeed stories are created every 30 minutes. We send 5 billion real-time messages out to mobile phones and to desktop computers in 30 minutes. 10 billion profile pics, thumbnails will be served. 108 billion queries on our MySQL tier will be performed. 200 billion objects will be checked at display time. 300 million of those objects will be blocked. And finally, 3.8 trillion cache operations will be performed in the next 30 minutes. So, okay, we have a lot of users, we serve a lot of traffic, we store a lot of bits. So what? The number of trailing zeros will vary over time. New code will be written, crappy code will be deprecated, and the product will change. The people using your product will also change, and vendors will come and go. At Facebook, our technology is changing all the time, literally every day. But the underpinnings of how we work has been constant and has been with us for many years. There are a core set of principles that have helped us scale from 1 to 10 million users, 10 million to 100 million users, and is helping us scale from 100 million users to 1 billion and beyond. These core ideas are at the very center for how we build our infrastructure, how we scale it, and how we operate it every day, and I want to share these with you today. So the first principle I want to talk about, actually, is the next slide. Sorry about that. The first principle is focus on impact. It's a pretty straightforward concept for most of us, and I'm sure that you all talk about it at your own companies. However, at Facebook, it actually begins the moment you walk in the door on your first day. Everybody that starts in a technical track at Facebook goes through a program that we call Boot Camp. Boot Camp is designed for everyone. Again, whether you're a VP with 20 years of experience or you're straight out of school, everybody goes through Boot Camp. You can't skip it. So Boot Camp is designed to immerse new engineers in our code base, and it also helps us promote the types of habits we want to scale up our organization. So what is Boot Camp like? Well, let me tell you about my first couple days in Boot Camp. When I started at Facebook nearly 3 years ago, I showed up for my first day of Boot Camp. I found my desk in the Boot Camp area, conveniently called the Boot Camp Cave. I logged in. I saw that I had 4 emails from Facebook. The first one was a welcome email. The other 3 were tasks to go fix bugs in production already. So I was already feeling pretty behind. I set up my development environment, got a local copy of Facebook running. I dove in, tried to understand the code and what was going on. I picked the easiest task that I could, and that was to add a feature to our group's product at the time. So a couple hours later, I had my fix working. I had it tested. I submitted it to our code review tool. We use a tool called Fabricator that we open sourced last year. You should check it out. Next day, it was merged and actually pushed out to a few 100 million users. So think about that. My second day in Boot Camp, I was able to take some code that I wrote and ship it out to several 100 million users. And so that's what we really mean by focusing on impact. We have a rotating set of senior engineers that we call mentors that meet and coach with, the boot campers and are there to basically coach engineers to be more effective. They review code from the boot campers and give them feedback on how they're doing, but they also hold office hours to just answer general questions about boot camp. Boot campers are required, mentors are required to wear funny hats so that they can be easily identified. And also, we have a set of senior engineers from throughout the organization who come in and give tech talks about the various technologies we use and develop at Facebook. So one additional bit here is that all of our ops engineers are also required to go through boot camp as well. So they attend the 6 weeks of Eng boot camp, so they too can learn the tools, the site's technology, as well as the code to do their job. After the 6 weeks that they spend in Eng boot camp, they will go off and do another couple of weeks in a program that we call, conveniently, Ops Boot Camp. And that boot camp program will teach them all of the tools and sort of tricks of the trade that we use to operate and scale our services. Bootcamp is also designed to educate new engineers about the opportunities that exist across the entire company. So what we optimize for is that engineers get to pick a team that they're excited to join and where they feel that they can make the most impact. We don't use a hiring committee to decide where engineers should go based on a limited set of interactions that we have with them during the hiring process or the interview process. So instead, engineers are able to join a team that they want to, that they're excited to, in their 6th week of boot camp. So as bootcamp has evolved and improved over the years, we've found a couple of additional benefits. So one is that by centralizing the mentoring and onboarding of responsibilities, we've dramatically reduced the hiring costs across the entire organization. We've done this in a way that it helps us keep our the time we spend showing people the ropes and also keeping our standards consistent to a minimum. It also helps us take our rapid organizational growth in stride. The mentor program that I just spoke about also has created a great opportunity for us to develop leadership internally, and it serves as basically a meta boot camp for future tech leads and for future managers in the technical organization. Finally, the last surprising kind of benefit that we've seen is that some of the boot campers form bonds with their fellow classmates, and those bonds they take with them as they join different teams, and those bonds and relationships are things that help cross-functional communication and prevent siloing effects that typically emerge in big organizations. So as bootcamp continues to evolve and improve over the years, the one thing that is constant is that the new engineers that started at Facebook yesterday, being Monday, will still be expected and will still ship out something to nearly 1 billion users by the end of the week. So I want to move on to the second core principle here, and that's moving fast. Moving fast is essential to our success. It's essential to accomplishing our company mission. Speed is important because you get to see your idea, whether it works or not, with very immediate feedback, without losing motivation and without losing focus. It starts with 100% engineer of all of the code and of the feature with every engineer in the company, but moving fast does not mean slipping and slacking on quality either. We want to continue this high velocity of shipping stuff to our users, but we want to make sure that we're doing it in a way that removes friction throughout the process. So you'll see here a graph here of basically commits per month. We've worked really, really hard to not lose the momentum of shipping stuff. This has scaled nicely as our organization has grown over the years. Normally, this will flatten out as you add more people and as you add more process to your organization to keep it running. So we today push several hundred code changes out to nearly 1 billion users every day, at least once a day. We invest a lot in the tools to keep the site stable and also fast during this time. We do pushes in the middle of the day as well, so we don't do this Friday night or Saturday night. We don't shut the site off. So we've invested a lot in the development tools and also the release tools so that we can do these types of changes in a massive scale pretty much anytime we want without actually impacting our users. I want to share a couple of tools and techniques that we figured out over the years that have really helped us kind of scale this process and scale the ability to get stuff out into production. The first tool I want to cover here is a tool that we call PerfLab. PerfLab is designed in a way that it tests every code change that is committed by engineers. So we take a sanitized sample of traffic. So we take production traffic, we sanitize it, and then we basically run that against every diff that a engineer commits. The great thing about this is that it catches a wide range of regressions that would then normally show up in production. So we're able to catch those, fix those before they ever show up in production and impact our infrastructure or impact our users. So this is a great thing for us, basically ensuring quality and helping us to move fast. that it tracks a bunch of really cool backend metrics as well. So we can track things like CPU usage, memory, data fetching, et cetera. But we can also track a bunch of front-end metrics that would impact browser performance, such as bytes served, et cetera. Today, PerfLab is running, let's say, about 10,000 tests a week on a base of about 1,000 engineers in the org today. The other thing that PerfLab is actually really good at spotting is these little regressions that happen over many weeks or many months. These things are almost impossible, as most of you know, to then go back and debug and to fix later. So this is actually a great tool for us to actually see these slowly drifting kind of skews in our performance. The second tool I want to cover here is a tool that we call Gatekeeper. This is a tool that is our primary vehicle for doing such the rapid experimentation that we do today. So if you're familiar with A/B testing, it's essentially an A/B testing framework on super steroids. It is a way for us to separate the actual release of the code versus the activation of the feature in production. And it's the same tool that we actually use to phase out and roll out a feature to all of our users. And we can do that in a bunch of different dimensions. So we can base it on geo, we can base it on browser, we can base it on type of user, we can base it on gender. But typically we would roll out a feature in phases, and we can do something where we may do 0.1% of the users, 1%, 10%, 50%, and eventually get to 100%. But we can do that activation of the feature kind of at our own pace and not block and impede the release process itself. We regularly run thousands, maybe even tens of thousands of experiments at any one time in production today. And you can see here, the code snippet is actually pretty simple. It's just a set of conditionals around whatever code you want to execute or not execute. And the evaluation of that logic is then determined by the setup that you put into the Gatekeeper console, which is the screenshot on the right. To give you an idea of how busy or how heavily we use this system, today, on average, there are 500 million Gatekeeper checks per second that are being executed across our entire site. So this is something that's really, really essential for us to be able to move fast. The stuff before that I talked about was mostly focused on our www or our PHP code base. But I believe that moving fast also applies to backend stuff. We have a lot of smart visualization that we've deployed and sort of built over the years. This is a screenshot of a tool that we call ClassBin, and it's a high-density heat map viewer for big distributed systems in our infrastructure. So it allows us to gives us a bird's eye view into a large set of servers. We're able to spot kind of oncoming or up-and-coming problems and be able to drill down very quickly with just a couple of clicks. So this has saved us countless hours in terms of doing lots of crazy log munging and random SSHing into hosts. We can quickly check this, see what the pattern might be, whether it be a rack, whether it be a data center, whether it be a row of servers, and then be able to kind of pattern match and then employ sort of further debugging skills from there if we need to. ClassBin is regularly used on services that span anywhere from thousands or tens of thousands of actual servers. The last thing I want to cover here is actually a technique that we've kind of figured out to speed up some of the deployments for our backend services. Now, we're all pretty much used to this scenario, right? We have a process, there's some memory or cache that this thing needs to have. We bring in requests, the cache fills up, awesome, great, we're off and running. But now, version 2 of the binary comes along, so we have to drain the traffic from the server. We shoot the process 1 in the head, and then we roll out the new binary, v2, and then we start it up. But this is left with an empty cache, so now what ends up happening is we have to slowly stagger the restarts and the deployment of this new binary out to the infrastructure. And this becomes just something that takes more time. It goes into the evening hours, weekend hours. It backs up the release and engineering pipeline as well. So at Facebook, we got pretty tired of this because it was not scaling very well for our sprawling sort of server fleet. What we did in a hackathon is actually take the execution engine and separate it from the cache. We use a shared memory segment to connect the cache to the execution engine. And so now what happens is if we want to roll a new sort of logic in the execution engine, we can again drain the traffic. We can shoot the v1 process in the head. We can roll out the new binary and start the new binary and very quickly bring in traffic to that new process again. But here, we've preserved the cache on restarts. Now again, this only works if the data structure of the cache is actually consistent from one version to the next version. If you change the data structure, then you actually lose the cache and have to do a full restart. But now the impact to us was actually pretty dramatic. What used to take us time, sort of maybe weeks, even months, to deploy a new version of some of our back-end stateful services now is cut down to days and sometimes even hours if we need to. So we invest heavily in these tools, provide lots of optimizations for what we do. It's helped us scale to 1 billion users. The key thing here, though, is that it's not done by a single person at Facebook. It's not even done by a single team. I would say that basically every engineer at Facebook, every operations engineer and software engineer in Facebook, at some point in their career will have contributed and built one of these tools or added features to these tools. So we've spent a lot of time kind of building up the internal tool stack so that everybody can contribute and make them better over time. The operations team has a huge hand in this. We do software development and operations team. We've taken a lot of time to sort of get that ingrained and get that correct inside of the organization so that it's not a divide between sort of engineering and operations here. Over time, we've realized another major benefit, which is it's kept our work actually a lot more fun and a lot more interesting. A lot of the mundane stuff that takes time out of your day and creeps up day over day as time progresses here is automated away. We can focus our energy on the things that matter and actually propel the business forward. For example, we built a remediation system a couple years ago. This remediation system does a bunch of very simple and sort of very mundane and tiring things that would normally consume time. Recently, we measured its effectiveness in the organization, and this system is basically doing the work that's doing the equivalent amount of work to 350 operations engineers. So all of these sweet tools are helping us get to 1 billion users for sure. But I want to stress that the people behind the tools, behind the infrastructure are the most important thing. Simply stated for us, it's people, tools, and way, way, way down the list is process. So we work really hard to find great people, and then we basically allow them to build tools, or they build the tools that they need to move fast. All right, so moving on to the third core concept here, or principle, is what we call being bold. So being bold in terms of our infrastructure means going someplace new. Our product teams never sleep at Facebook. They're constantly coming up with new crazy shit. Mark has never once come up to me, Mark Zuckerberg has never once come up to me and said, hey Jay, I think the Facebook infrastructure is awesome. You guys delivered everything you need to do. Nice job. Why don't you go home and take a vacation? Right? We constantly have to rethink everything we do. As we build our software and hardware infrastructure that powers Facebook, it's absolutely critical that we design and build it for flexibility. To me, flexibility in our infrastructure means building it in a way that allows our product teams to iterate rapidly when they're trying to figure out what that idea is that makes a lot of sense for our users. So they're constantly iterating, trying a lot of different things out. But once they found that magic idea, it needs to be able to be launched to nearly 1 billion users overnight. And that's what I mean by flexibility and building flexibility into our infrastructure. So I want to give you an example of where we were actually being bold in building our infrastructure. So let me go back to about 2010. We started building this data center in Prineville, Oregon, also known as PRN. We took a pretty innovative approach to this data center. We use 100% outside air cooling to cool the servers, and we built a simple but very efficient electrical distribution that powers the servers. Many of you are familiar with the term PUE in the industry, which is a power usage effectiveness. The best number that you can come up with is a value of 1, but the industry average today is about 1.5. So that would mean that 50% of the energy that you pull off the grid is actually thrown off as heat or as waste. When we brought up Prineville and did our PUE measurements, we came in at 1.07, so that's dramatically lower than 1.5. This project took us about 12 months to build and have it ready for live traffic. We learned a lot from this big scale project. It was a pretty good success, but as we normally do at Facebook, we did an extensive postmortem on the entire project from tip to tail. The biggest thing that we came out, or the biggest takeaway that we took away from this whole project was that it worked pretty well for us and that we were going to lather, rinse, repeat, and just apply it to the next data center that we were going to build. So the next data center, moving on, is a data center in Forest City, North Carolina, also known as FRC. We kicked off this project thinking that we would just copy everything that we learned and did in Prineville. We completed it in 10 months instead of 12 months, so we were able to shave off 2 months, and we did it a lot cheaper. So that was pretty cool, but that's not the full story. So instead of keeping everything the same and just celebrating our success here, we actually ended up changing everything inside the data center, the network, the servers, and the software. But why the hell did we do this? Well, again, we got to keep moving. Our product teams keep building products, and our infrastructure needs to be even greater over time. So big products that we launched last year, like Timeline and Open Graph, we're going to, and today, put an insane amount of demand and stress on our infrastructure. So we have no playbook to kind of figure this out, and we just have to drive as aggressively as we possibly can and be constantly rethinking the entire premise and all of the assumptions that we have when we build out this infrastructure. So here's some details of the things that we actually changed. I'm going to start with just the servers themselves. So you can see here on the left is the version 1 of our web server. We have 6 different models of servers that we typically deploy in production. This is one of the 6. The version, or the picture on the left here is version 1. This is what went into Prineville, Oregon. The other one is version 2 on the right is what went into Forest City. So the first thing we changed, it's actually pretty simple, but we moved the drives from the back of the chassis to the front of the chassis. This was a pretty simple change, but it made the lives of our data center technicians far, far, far simpler. It was much, much easier to do the repairs. So not only is CapEx cost important to us from an infrastructure perspective, but we really do care about operational efficiency and human time in operating our infrastructure. Today, we operate with roughly managing about 15,000, maybe even north of 15,000 servers per data center technician. That's sort of unheard of in our industry, but it's because of little tweaks and optimizations like this that we're constantly looking for that allow us to get that great scale. The second change we made here is we actually increased our density. So we went from 1 motherboard, which is on the left side here, to 2 motherboards. The big thing here is obviously outside of just getting more power or sort of more performance out of a per rack unit here, we were actually able to share components. So the power supply, the chassis itself, et cetera, were all actually shared across the motherboards, and we were able to drop our costs down. The third and final big change that we made, and keep in mind all of this actually transpired and changed over just a few months, is we upgraded from a Westmere processor on the left here to a Sandy Bridge processor on the right. We had better per core performance, we had more memory channels, and we had faster memory speeds, which resulted in us basically getting a 40% improvement in throughput on our web tier workload. We believe that we were the first in the industry to actually push Sandy Bridge into production at such a massive scale. And again, this is one example or one model of servers that we changed. We also changed all of the 5 at the same time. So at the same time, while the data center was being built and we were designing and building these servers and working out the kinks, we also took a look at our network. So to give you a little bit of context, here's a graph of our network growth needs. You can see the green and blue lines at the bottom here. There are traffic going in, coming to and from our end users. It's a pretty stable line, and capacity planning for this is pretty manageable and not that interesting. However, we have many dozens of services in the back end of Facebook that all need to talk to each other, and they're talking more and more to each other, and they have more and more data to deal with. For a single web request that we get from an end user to our infrastructure, that results in hundreds of concurrent back-end requests. Those servers are processing tens of thousands of objects of data, essentially in parallel in real time, and we have to serve that all back and render a page in less than a second to a user. So we had this massive fan-in problem, right? Because we have all of this traffic coming in from these servers back into the web tier, and it puts a huge strain across our network infrastructure. We studied our traffic growth here, and we found that the service communication was going through the roof. It was faster than we ever imagined, so we were forced to kind of rethink our entire network architecture in the same time frame here. So here's a very kind of dumbed down, simple, high-level architecture diagram of our data center network. We have data center routers that basically connect all of these different clusters. We have different clusters. We have a web sort of front-end cluster, we have a back-end cluster, and we have the services cluster, which is kind of everything else. Over time, these clusters basically learn, and basically the code that changes cause them to talk more and more with each other. So you can probably guess where the bottleneck here is going to emerge. Right, so it's the data center routers. The DERs were basically on the point of melting for us. You can describe them, or we can describe them as sort of feature-rich but port density poor. We could have added a lot more of these, but they're extraordinarily expensive for our taste. Across the DR tier themselves, and there's 4 of them, they have an aggregate capacity of 5 terabits, a little over 5 terabits per second traffic-wise, but that wasn't going to be enough based on our capacity modeling. And keep in mind, this is just within a single data center, and we have many data centers. So we're all scratching our heads trying to figure out what we're going to do about this. Well, what's the solution? Of course, we added bandwidth, but how do we do that? Well, it's not a rocket science type of solution here. It really is just sort of a get shit done solution. We really kind of tried to keep things simple here so that we could actually accomplish what we needed to do here. We moved from an L2 topology, a layer 2 topology inside the network, to a layer 3 topology. What's interesting about this is we actually run layer 3, or we run BGP all the way down to the top of rack switch. So we run BGP all throughout the data center. There's one protocol that everybody who's on the network inside the data center understands. We can build tools around, we can debug all uniformly. So it makes it much easier from an operations perspective. A common max ARP table size for off-the-shelf silicon today is about 6,000 entries. We were able to, with this architecture, reduce it down by a factor of 30. So based on that, we're actually able to now, going forward, look at larger and larger cluster sizes because we're not bound by the silicon ARP entry size here. And then finally, we were able to achieve a 12x improvement within the bandwidth within a rack, which has helped us open up all of our service and provide better performance for all of our services. So again here, here's a list of things that changed. It's probably a shorter list to describe what didn't change, but we literally changed everything, and even down to the cables. But there's more. So in the meanwhile, while we're changing all of the servers and all the network and building this other data center, we had several other data center projects that are also going on. Here's a cool aerial shot of our snow-covered data center in Sweden, and this is our latest project that we're working on. So being bold is the next kind of topic I want to talk about, or I've been talking about. But being bold at Facebook means doing big things and doing them in parallel, no matter how big or successful we are. We can't rest. We can't afford to do them serially, and we can't do them one at a time because we just don't have the time to do that. We changed everything in our data center, and we'll probably change it again for the next one. We changed the servers, the network, the data center itself, and are changing the software to take advantage of this, all in a span of months. So that's sort of the frosty side of the flake. This doesn't come easy. This took a lot of hard work. We had to, along the way, come up with a lot of backup plans. We didn't want the entire mega project to go off the Richter because one part of it went awry. So we were constantly looking for insurance policies and other backup plans along the way as we're managing all of these concurrent projects. The one big takeaway that I want to tell everybody about, and it was a big takeaway for me, is that it's really important to get the organization aligned behind such a big cross-functional effort here. You have to look at your org structure, you have to look at your leadership, and making sure that everybody is actually focused on a core set of goals if you want to accomplish so many big things and so many things that span many different functions across the org. Okay, so being bold in this term doesn't mean being wasteful. Planning capacity for our infrastructure is a crazy complicated problem that we deal with on a daily basis. We want to build the most efficient and the most cost-effective infrastructure we can. So how many people here have asked for servers or been asked for servers from some new project? I'm sure everybody, right? So what's your typical answer you hear or say? So we try to avoid this answer at Facebook. Our approach is that basically capacity planning and performance engineering is one and the same thing at Facebook. We try to get teams what they need so that they can move fast, but we also need to make sure we stick our budget. The team is composed not just of analysts and people who create spreadsheets and push them around, but it's actually composed of performance engineers, people who understand and write code, people who understand performance, who understand big-scale architectures as well. This team has a global view of our entire budget. They make sure we don't run out of capacity. In fact, they have to make sure we never run out of capacity, but we also have to meet the budget and meet our financial responsibilities. The cool thing about this team is they know where everything is, they know how it's being used, and they can direct the different efficiency efforts to the different parts of the organization based on this global view of what's happening. There are many different ways to add capacity to a service or to offer capacity to a new service. It doesn't always mean adding servers, though. We have a variety of tricks that we can do from software to hardware to give a team additional capacity without just throwing money at the problem. There was one instance that I want to tell you about today where one engineering team came to the capacity team and said, we need 8,000 servers and we need these servers by next week, and we need them in 4 different regions. And so the capacity engineering team said, well, let's sit down and talk about this for a little bit. So a couple days later, they came back out and said that after they looked at the architecture, they looked at the need, it was deemed acceptable by both teams that this team got 16 servers instead of 8,000 servers. So that's a pretty good cost win in terms of the impact that this team has across the business. So last core principle I want to talk about is being open. I believe this is a critical concept or a critical principle if you want to move fast and be bold. I don't think you can do the other two if you don't have this sort of ingrained in your culture. However, I'm going to illustrate this idea by going over a little problem we had in production in late 2010. Some of you in the audience might even remember that, and frankly, I think this is probably the strangest incident I've ever lived through in my career. So there was a bit of press around our problem, but in a nutshell, we launched basically every secret feature that we were working on to all of our users at the same time. Pretty cool. Not. So this graph normally should depict a flat line. This is our bandwidth egress to our users, and this should be pretty flat and steady throughout this period of time in the day. So at about 12:15, you can see the problem started to happen. We noticed many services were backing up, and the web servers were backing up and starting to crash. Right after this, you can see the steep dive in egress. Around 12:35 or so, we figured out that we could shift some traffic around. We took some traffic away from the hot clusters themselves. The web servers started to recover a little bit. Egress then picks back up. At around 12:40, we're still investigating, trying to find out what the heck happened here. And we discovered that one of our new features, live comments, you're probably all used to using this today, had been inadvertently 100% launched to our users. It was still a feature that we were working on internally, and it wasn't ready for prime time. But we thought it was actually pretty clowny that somebody would launch this without telling anybody, because it was a major feature that we were working on. But we still actually had no idea about what was yet to come here. So we went ahead at around 12:50 or so and turned off live comments, and we're thinking, hey, everything's good. Egress is going to recover here. So it starts to go back up here. And at 12:51, we figured out that egress is way above what it normally should be. And then, based on some internal reports and other media coverage, we realized that we had launched everything out to our users. So that is, every feature that we had been secretly working on that was basically hidden or restricted behind a gatekeeper check, which is the tool I covered before, was actually failed open to the world. So this constraint around is employee basically always evaluated true for every user. So at sort of 1:06, we realized that the fix was going to take a little bit of time, but we couldn't leave the site on and out there with all of these features, right? So while we worked on the fix, we said, okay, well, we got to turn the site off. I went up and told Mark, hey, we're turning the site off. He was like, well, okay. He didn't really have a choice. I didn't give him a choice. But we had a little problem. We had never taken the site down at our scale. So we tried everything. All of our tools, nothing worked. We couldn't turn the site off. So we finally resorted to the caveman approach, yanked DNS. The site came down, and we worked on the fix. We fixed Gatekeeper. We brought our services back online, and then eventually egress would return. It took us a while because DNS took a while to propagate as well. So this wasn't really a great day for us. We take these types of mess-ups pretty seriously in the team. Mark tried to lighten the mood with this status update internally. You might be asking what also then happened to the engineer who introduced this bug into Gatekeeper. He had a bunch of friends actually calling him externally, being like, hey, dude, are you fired? You still have your job? In fact, we didn't actually fire the engineer. He's still one of our very best engineers today. But instead, we focus our efforts on doing better. We learn from our mistakes instead of sort of punishing the mistakes. We have a very diligent sort of regiment SEV review process every week. We sit down and review all of the production problems. We have various people from the infrastructure team attend this meeting, so we get a wide variety of different opinions, from ops to engineering to product to other types of people in the room as well. The conversation usually looks like we cover the timeline, we look at the impact, we look at the root cause, we come up with follow-up actions. We track these actions to make sure we don't make the same mistakes twice. But we also are careful not to come up with silly metrics like reduce the number of SEVs we have. We focus on reducing the time to recovery and other things, and we try to make all of the actions that we come up with actionable, and we track them and make sure that we actually get them done and fixed. So from this specific SEV, we had two action items. One was to make Gatekeeper itself more robust and not to have this type of failure. And the second thing, kind of obvious, we built a tool so we can turn the site off next time. So this logo, Fix More, Whine Less, symbolizes our attitude that we're all one team. We help each other, we don't blame each other, we don't hang each other out to dry. There's no whining. Instead, we focus on what gets in the way of shipping stuff. We try not to add process, we try not to penalize our employees. We often say move fast and break things at Facebook. That involves taking risks, but it's the job of the Facebook infrastructure team to make sure that when things break that we don't impact our users. We apply rigorous learning everywhere we can. We spend half of our time innovating for the future, but we spend the other half learning from the past and the present. We're focused on building flexible infrastructure so we can ship amazing products that will be used by billions of people someday. We remind ourselves every day of how much more there is to do. This time-lapse video is playing some of the construction of our new campus. The principles and examples that I shared with you today form what we call the Hacker Way. This mindset and culture is so important to us that we've actually poured it into the concrete of our new campus. The Hacker Way is the best and most important thing we've built. Thank you, everyone.